Alright students, let's look at this question here, which is on complex numbers. So it was taken from the year 2017 CJC Paper 2 question 4. Now you're given that the complex numbers z and w satisfy this simultaneous equation, and we are told to just solve this. Now what I'll usually tell students is simultaneous equation is similar with what you learn in secondary school, instead that now it's just in complex numbers. So there are some additional tricks to do. So this case here, I'm going to use substitution. I'm going to make z the subject. I'm going to substitute to one another, right? So I'm going to make z a subject here. So from the first expression here, a, let me just write it down nicely. Here, what we get is a is equals to z equals to 10 minus w conjugate minus 5i. Okay. So from here, what I get is z, make z a subject, and we're going to sub into the second one. So sub 1 into the second equation, z plus 18 plus I. Okay, then what we're going to do is actually just replace this modulus w square is equals to 10 minus w conjugate minus 5i plus 18 plus I. Okay, then we're going to do here is just add everything up. This is 28, 28, yeah. 28 minus w conjugate minus 4i is w modulus square. Now, so now we have everything in terms of w. So w conjugate and w. So just let w equals to a plus bi, complex number where a and b are real values. Okay, this is important. Essentially, you need this to be real value here. Then what we're going to do is actually just replace it in modulus a plus bi square equals to 28 minus. So this case here, so this will imply that w conjugate is a minus bi. Okay, so this is a minus bi minus 4i. Then just expand this, which is a square plus b square. Let's replace this. A square plus b square equals to 28 minus a plus bi minus 4i. So this will just be a square plus b square equals to 28 minus a plus b minus 4i. Okay, so now with this, what we can do is actually compare the real and the coefficient, the imaginary, because this part here, you can equate to both of them. So by comparing, once you have all these terms here in real plus imaginary, by comparing the real and imaginary parts. Okay, I'll just take note. This one here is real. This a square plus, so this is 0i. So b minus 4 is actually equal to 0. And after which, you have got the other one, which is 28 minus a is equals to a square plus b square. So it's pretty okay. So b minus 4 equals to 0. So this is b equals to 4. Then we have a square plus b square equals to 28 minus a. So this is a square plus 4 square equals to 28 minus a, because b is 4. So this case, a square plus a equals to 16 minus 28. Let's key this in. 16 minus 28, that will give us minus 12. Oh, this is pretty nice. So then we're going to get 1 minus 12. This is a equals to 3 or negative 4. Okay, so there's our b there. So we get w. Yeah, w has got two expression here. So it makes sense because b is 4, right? So w is actually just a plus bi, so it's 3 plus 4i or minus 4 plus 4i. Okay, remember that w is a plus bi just now, this one. So just replace it in. So we have two possible answers here, after which we're going to just use z equals to w conjugate. So z, this corresponding here, this z will be using this formula, 10 minus W conjugate. 10 minus W conjugate will be minus 4i. Okay, maybe this conjugate here. Minus 5i. Okay, after which this will follow the same. It's 10 minus 4 plus 4i. W conjugate minus 5i. So just key in this. 10 minus 3 minus 4i. 5i. This will just be 7 plus 4 minus 1 minus i. Then this will just be 10 minus 4 minus 4i conjugate. 10, 14. This is 14 plus 4 minus I. Alright, so there you go. So hence we have the solutions. The two solutions are actually 3 plus 4i. Z equals to 7 minus I, semicolon. This is one set of solution here. And then we have got another one which is W equals to minus 4 plus 4i. And this will be Z equals to 14 minus I. Okay, so that's how I do this question here proficiently. If you have any questions, please let me know. It's a pretty interesting one. And let's look at how we can do the next one.